Okay, hello everyone. This is the final video in this series. I'm going to try to sum up the statistical process of determining the underlying condition. What you've been watching in the first 6 videos is basically step number 3 in this graphic, where we've been showing you all of the various advanced ECG techniques as shown here, and basically then producing the results, at least the ones that are displayed in our programs. There are several others as well. Of course, one also has to first collect the data. That's sort of step 1 in the graphic, and then also securely move the data files to us before we could perform step 3, which is what we've been showing. But what I'm going to cover in this video is really step 4, where we're going to take the results and put it into our database, and also step 5, where we display the results for the individual subject or patient against the results that are already in the background of the database for patients that have known disease or health based on gold standard imaging. And then we're also going to go over a little bit of aspects of the display. For example, number 5 there, we can put things into a discriminant analysis to give us a feel for where our patient lies versus the patients in the underlying database. And we'll talk a little bit about some scores as well. Here, we're just going into one of our databases, a statistics database, just kind of showing you. You can see the ages and the genders there of the patients that are in videos 1 through 6 in chronological order there. And you can see their ages and gender. Gender 1 is male and 0 is female. We just had 1 female, the second patient. And you can see right off, this is actually starting with some HRV results. You can see only the first 3 patients who had full disclosure or 5-minute ECGs have HRV results. Whereas the other 3 patients, 4, 5, and 6, do not, because they only had a 10-second snapshot ECG. Same will be true for things like QT variability, which we'll get into here. Some of these parameters are from the QT variability. So 4, 5, and 6 don't have those. They only have the snapshot ECG. Just patients 1, 2, and 3 have the full disclosure. Now here we get into some of the signal averaging and other 3D ECG, T-wave complexity parameters. So some 3D ECG parameters like this here that involves a coefficient of variation that combines a temporal aspect, you won't have those in the snapshot ECG either. But I just want to show you just the wide, huge variety of parameters. This is really big data as we kind of slide through just to show you the variety of parameters. Way too many to explain. We sort of graded, you can see the colors there in terms of high or low, or where they stand in relation to the underlying healthy population in the database. So let's just kind of finish up scanning through some of those 3D ECG parameters. Let's move on and let's go into an area where we actually are showing some of our score results. We'll look at a formula for one of our scores. So this is a score that just looks at disease versus no disease. You can see it's a constant plus some coefficient times the result of a given parameter, and they're added up in a score. This was derived by logistic regression. This is a 9-parameter score. You're seeing some of those parameters and coefficients in that score. So this was basically, again, just a disease versus no disease score. That's the first thing we look at. This is by the snapshot ECG, so all the parameters in here are derivable from the snapshot. We can see then what the result is of the score. And the only person with a negative result is the first person. That was our healthy 25-year-old male. So he does not have disease by the snapshot ECG, whereas you see in the 4th column here that everybody else has disease. The number 1 there indicates disease, the number 0, no disease for that snapshot score. We can also look at a full disclosure score. So not only the first 3 patients will have results for this one because it requires a 5-minute ECG. There are QT variability parameters that go into this score, a couple different ones. Same general concept though, fewer parameters, a little bit more power in the full disclosure ECG, so we don't need as many parameters to get at our answers. All in all though, we can eventually see that the same results occur for the first 3 patients. The first one is judged to be healthy, and the second 2 are diseased by, there we go, the 6th parameter full disclosure ECG score. So that's a general idea of disease versus no disease scores. We can certainly also have other varieties of scores, and we're constantly iterating our scores as well. For example, here's another full disclosure score that just adds another parameter. Might add a little bit more sensitivity and specificity. So that's a general look at disease versus no disease scores from the logistics side of things. We can also do another score. This is for left ventricular systolic dysfunction. So we're looking for the possibility by ECG of a left ventricular ejection fraction less than 50%. This was published as well in 2010 in one of our papers. And we can see here now that in this score, everybody looks like they have a ejection fraction over 50%, except for patient number 3. And if we look in detail at patient number 2 now, remember all the disease scores were positive for patient number 2. That was our diabetic, but the LVSD score is negative. But here, patient number 3, the male, has a positive LVSD score as well. So most likely has some degree of heart failure by the LVSD A-ECG score call. The others are negative. Remember, this is also a snapshot score. We can get that LVSD call with just a snapshot. And so the 3 snapshot guys, even though they had positive disease scores by the snapshot, they have negative LVSD scores by the snapshot. All right, so only the first one is free of disease. Only the third one has LVSD by the logistic scores. Okay, let us move on then. Now we go into discriminant territory. Now we really like this technique in terms of its ability to visualize where your patient lies versus the underlying groups in the database. This is the healthy database. We're showing number 1 who lies up there. Result comes in healthy. This is coronary disease group down here. Left ventricular electrical remodeling group, or essentially left ventricular hypertrophy or enlargement, talking anatomically. Non-ischemic cardiomyopathy and ischemic cardiomyopathy groups, a hypertrophic cardiomyopathy group, and finally an ion channelopathy group that's made up of mostly long QT patients. So our patient number 1 is essentially orbiting the healthy planet, so to speak. You can go down and see what the discriminant actually calls for patient number 1, and indeed, there's a bit more fineness in our diagnosis here. It says healthy, so resembles a healthy patient in the underlying database by greater than 99%. So that's consistent with where the location of that dot is as well for number 1. Let's go in and unhide number 2. Remember, this is the person who had basically a normal ECG, just a slightly prolonged QTC interval. It was really the only abnormality on a conventional ECG, and she is winding up into the coronary disease group. Not by much. We can see right around 60% looks like coronary disease, the other 40 or so like healthy. So I chose that example because this is a single vessel disease person, normalish ECG, and here the discriminant is just barely picking up that coronary disease. Positive disease scores as well by the logistic. Remember, both the snapshot score and the full disclosure score were positive. Now let's look at number 3. And remember, this was the patient that had a slightly more abnormalities, some T-wave changes, but still a non-specifically abnormal ECG. And we can see that this person, this man, ends up out in the cardiomyopathy territory. It's actually the non-ischemic cardiomyopathy territory if we refer to the call by the database itself. So orbiting that particular planet out in the outer solar system, about as far out as we can get. But again, only a non-specifically abnormal conventional ECG. Let's go to number 4. Remember, number 3 also had the positive LVSD score, so that goes along with the discriminant call as well. Number 4, here, this was a guy with a normal ECG, but remember we had some hints of LVH by the 3-dimensional ECG, and he indeed is orbiting the left ventricular electrical modeling, LVH, LV enlargement sphere, and pretty firmly into that category in spite of his normal conventional 12-lead ECG. Let's go on and take a look also at number 5. Remember, number 4 had positive disease scores as well by the logistic snapshot score. Go in and look at number 5. This was the person who had borderline conventional ECG criteria, Cornell Voltage criteria for LVH, a 39-year-old male. And other than that, though, there wasn't much, maybe some T-wave changes. Here we've got, though, a call right around that hypertrophic cardiomyopathy. So this is a special type of LVH that the discriminant is calling based on the background data, saying that this 39-year-old male likely has hypertrophic cardiomyopathy, a very strong score for that. And finally, we'll look at our sixth patient, who was the 14-year-old male who had a normal conventional ECG, but positive logistic score for disease, negative logistic score for LBSD, and a long spatial JT peak interval as corrected, a couple other minor 3D ECG abnormalities as well. And so we can see there he is, number 6. He looks like he's orbiting that ion channelopathy or long QT syndrome planet. Indeed, if we go down and look, that's exactly where he ends up as well, in spite of that normal conventional ECG that had a normal QTC interval, remember that. He also has one other abnormality which you can look at on his report, which is on the website elsewhere. Go ahead and maybe have a look at that if you're particularly interested in long QT. Here we're going to go and look at things three-dimensionally at the same plot, basically. And this is real fun. Sometimes you can get a little deceived by the two-dimension, but if we look, number 1 ends up orbiting the healthy planet. Number 2, the coronary disease planet. Number 3 is actually closest to non-ischemic cardiomyopathy. Number 4 is smack in the middle of the left ventricular hypertrophy or left ventricular electrical remodeling circular sphere. Number 5 is orbiting hypertrophic cardiomyopathy. And number 6 is orbiting the ion channelopathy or LQTS circle. You can see how far away that is from the healthy circle. So the three-dimensional gives us a little bit better view. Just again, a recap of the conventional 12 ECGs. This was video number 1, patient number 1, normal ECG, ended up healthy on all of our A-ECG scores. Video number 2 was from the female diabetic who had basically a normal ECG, maybe slightly prolonged P wave. She ends up in the coronary disease sphere. Video number 3 was the person who had a more abnormal ECG with T wave changes, poor I wave progression, but still non-specifically abnormal, who ends up in non-ischemic cardiomyopathy. Video number 4 from the elderly male who had a normal ECG, but abnormal 3D ECG with abnormal angles and so forth, who ends up in the left ventricular hypertrophy category. Video number 5, the 39-year-old male who had borderline Cornell voltage criteria for LVH and also some minor T-wave changes, who ends up in the hypertrophic cardiomyopathy category based on his A-ECG results. And then finally, the last video, video 6 from the young 14-year-old male, normal ECG, but abnormal spatial JT peak interval and other spatial parameters, puts him into the long QT category. There's a summary again, 1 through 6, where they end up. And here we can see the final diagnoses again for videos and patients 1 through 6. And by the way, for the last 3 of these, you can go to the example A-ECG reports part of the site and see their formal A-ECG reports as well.